All right. Hope you folks had some snack and coffee and tea and bio break and so on. So after these 2 hours of overview and deep dive, so now it's time for interaction. So like I mentioned earlier, we have 2 panel discussions. Am I audible at the back, by the way? Please raise your hands. Okay. So we have 2 panel discussion. One is focusing on the 6G spectrum and where it is heading and so on and so forth. And then the second one is focusing on 6G based innovative applications. So for the first panel discussion, which is aptly titled Envisioning the Future of Wireless Communication, Unveiling the Spectrum and Air Interface Technologies, we have Dr. Balaji Raghotaman, who is going to be the moderator as well as the panel expert. So I would request Dr. Balaji to take the center seat and be the master of ceremonies for this panel discussion. So, like I mentioned, for this panel discussion, we do have the who's who from the wireless industry. And I mean, there is no specific order I'm going to call. It's just a random order here. So I would like to invite Dr. Rohit Kapoor, who is the principal engineer and manager at Qualcomm. Rohit, please. The next expert I would like to invite is Professor Radhakrishna Ganti. He is no stranger to the high-tech ecosystem. Professor, can you please come over? Then the next expert on the stage is Dr. Kirti K, who is the director at Samsung. Sir, please take stage. And we have Dr. P. Hanumanta Rao. Sir, if you can, high-tech industry. So with that short overview, right? So I would hand it over to Dr. Balaji, and Balaji is going to spend the next 45 minutes discussing threadbare on where what is the 6G spectrum, where it is heading, what are the challenges, and would like to hear from the subject matter experts and then draw a conclusion. Over to you, Dr. Balaji. Maybe a formal round of introductions.
Yeah, thank you. Thank you so much, Girish. So can everyone hear me? Is it audible? Okay, great. So thank you again for attending the panel. I had a long introduction to the panel topics itself prepared, but I think the last 2 hours have already been an introduction, so I will not repeat all of that again. So our idea here is to have a discussion on the various air interface technologies that we have been discussing today, and get the opinion of the experts here. So what I would request in terms of format is that rather than doing a full round of introductions of each individual panelist, when I ask the very first question to you, you can first take some time to introduce yourself the way you would like to, and also if you have any sort of specific thoughts on 6G that you would like to mention before answering that question, that's also okay. Please do so, and then you can dive into the answer to the question itself. And I would say about 3 minutes per answer, apart from the introduction and so on. If you could limit to about 3 minutes, so that we can have a maybe a follow-up or the next question to keep the discussion moving. Due to time constraints, we have the time limit on this. So that's basically the format. And towards the end, if we have time, I do want to open up to maybe 2 or 3 audience questions, so that we can have a more lively back and forth engagement as well. Okay, so let me begin. I'd like to ask the first question to Dr. Kirti from Samsung. So we have we are talking 6G, but let's start with 5G. Right. So 5G is now deployed everywhere, including in India, and 5G has FR1 and FR2 aspects to it. The key question is, the background is that globally there is some dissatisfaction with FR2, right? There is no beating around the bush there. So my question to you is, what in your mind are the shortcomings in 5G, maybe specifically with respect to FR2, and then if you have improvements in mind that may go towards 6G, what would they be? So.
Hello. So it's working. Okay. So my name is Kirti Keshav. I've been working in Samsung for past 20 years. To be specific, there are two Samsung in Bangalore. So I am part of Samsung Semiconductor India Research. Office is very near, almost 3 kilometers from here. And so about my background, I did masters from IISc Bangalore way back in 2003. And I've been working in Samsung. During my work at Samsung, I also got enrolled for PhD program at IISc, sponsored by Samsung, and thankfully I completed it while working. And over past 20 years, I have been working primarily in modem space. Started career in 2G space. Then we developed a 3G modem, and of course we developed our own 4G modem as well as 5G. So having developed 5G, now presently we are working on, from the India Center, on developing the latest enhancements to 5G, namely which are mentioned in release 16 and 17. For example, NR positioning, NTN, and NRU. So these are the development which are happening from the India Center, and we are proudly leading that team. And I can say that this kind of work is happening in SSIR, which is one of its kind in whole of India. Now coming to the answer to the question which Dr. Balaji asked. So as I said, from the background, we have more experience from the modem side. So how we see it from modem side, right? So there are two sides of the coin for that. So first coin is like, okay, whether the FR2 coverage is there everywhere or not, right? So the primary issue what we see is that coverage is the issue, primarily because the frequency at which FR2 works is, as you know, it works in a very short, to put lot of infrastructure to enable it. And whether operators are getting that kind of gain after putting that kind of infrastructure, that is the question. Like when we co-work with various operator companies, so they would like to reuse their existing investment what they have done in existing sites and so on. So they are very much, for example, NSA was very much successful. FR1 deployment was very much successful. And even when now our modem is getting tested across all the world, like Korea, whether it is US, whether it is Europe, everywhere we see that, the FR1 is everywhere, but FR2 is at very less places. The reason is, first is whether we have the right applications who are practically in today are using it, right? Second is the advantage of, the real, whether operators are able to make money out of it in comparison to what kind of cost they have to put in, the inability to use the existing infrastructure, trying to put everywhere the base stations and so on. So that is the one side of coin. Now coming to the technical side of it, which we see while working as, our own modem when we test with our modem with all over the world. What we see is that FR2, we see a lot of beam tracking failure, right, and beam management failure. especially at the high speed, right? So that's one practical concern what we see, and many times it becomes very difficult for us to prove, whether we are wrong or operator is wrong or the network is wrong, right? So, but of course we have ways to take care of that. I mean, we under the same condition, we test with the network reference phone also, and then we try to prove to operator that, see, even that is not working, right? So, however, that is one key issue. Frequency is very high and range is very small, and especially in FR2, both sides has to do beam tracking and management, even the modem as well as the network, and both have to align. So in theory, it looks very easy, and in the diagram also, it looks very nice that two beams are aligning with each other. But how to manage it practically? I mean, especially in high mobility, we see a lot of issues there. So that is one major concern which we are seeing. And of course, the second is the coverage. Coverage is going back to the first part of the discussion, which I said that we are not seeing that kind of coverage everywhere. And even though, I mean, initially it was mentioned that, readily somewhere at some sports we are able to see 600 Mbps, 1 GB, like that kind of speed. But how many of us are having 5G phone also, but not everywhere we get that. So we have to plug in the coverage holes seamlessly. And there are other aspects also which we see solely from the UE side. I will not go much into that. But for example, ours is a dual SIM phone. I mean, dual SIM management is not done by specifications as of now. So this is a little sidetrack, but phones are dual SIM, and phones are made dual SIM by reuse the same RF for both the stacks. So, right? So we have, if other stack takes the RF, and when you come back, so apart from, regular radio link failure and RR is what we see, due to mismanagement during the dual SIM management also, we see the issue. Apart from that, energy efficiency is, right? I mean, when using the FR2, the energy efficiency both on network side and both on the UE side is a forever solution. Coming back to the possible solution part of it, we are now working on NTN specification implementation, and we see that along with FR1 and FR2, together on top of that, if we have overlay of, for example, NTN, this kind of future practical deployment may help improve the coverage. Yeah.
Thank you. Thank you very much. That was a very comprehensive answer, and I think you've given us a lot to think about. So maybe from that, I'll pivot to a slightly different aspect of this. This happens in every generation, every new chunk of spectrum that's released. The question of the modulation scheme to be used, right? My question specifically here is, we all know what happened. 3GPP is a process. It's a long drawn process, sometimes very exhausting. And the final answer for FR2 was OFDM. So maybe I can, ask Professor Ganti here, do you, in hindsight, think OFDM was still the right choice for FR2? And also, moving towards sub-terahertz, what do you see the modulation scheme debate to look like?
Thank you, Dr. Balaji. Am I audible? Yes. Okay, my name is Radha Krishna. I'm a faculty in the Department of Electrical Engineering. I finished my BTech in IIT Madras, then went to the US for a PhD and postdoc, and back to Pavilion. I've been working in IIT Madras from the last 12 years almost. I'm a theoretician by training. I used to do interference modeling, point process, geometry, and other things. After I got back to IIT Madras, I was influenced by the analog group, and I started working on full duplex. That's when I started buying Keysight equipment. That's when I met a lot of folks around here. And slowly, I started getting into systems aspects of things. And one of the major assignments I've done is the 5G testbed. That's when I really understood 5G. I attend standards meetings, so we have been attending standards meetings, pushing some Indian IPR into standards and other things. But only when I started building it, I understood the complexity of the whole system, and I really appreciate the amount of effort that goes into this from a lot of people. Okay, so now coming back to this question, is OFDM the right choice of waveform for FR2, and going forward, will OFDM stay? Okay, so from a more theoretical perspective, OFDM is the ultimate waveform in terms of achieving your capacity. Okay, I mean, if you keep PAPR, your power amplifiers, everything aside, specifically for wideband channels, OFDM is optimal. It's well known in the literature, and a lot of math has gone in proving this. And from an implementation perspective also, people are very comfortable with OFDM. Okay, I mean, it's a nice thing. If you look at single carrier systems with complicated error control codes, those of you who have built this, you understand the complexity of interface between waveform and error control codes is much higher in 4G, specifically turbo product codes and other things, compared to how OFDM and LDPC interface with each other. They're very beautiful interface. I mean, they're meant for each other. Okay? And specifically when you couple this with MIMO, OFDM, LDPC is a marriage made in heaven. Okay, I mean, that's what people say. I mean, it's a beautiful combination. I mean, from an implementation perspective, from an analysis perspective. Okay, so it worked very well, extremely well in 4G, specifically up to a certain number of MIMO layers it worked. FR1, it was great. Even then, people know this issue of peak to average power ratio, so that is the flip side of things. Peak to average power ratio and ACLR issues were the major issues in FR1. So when people were looking at waveforms for OFDM, for FR2, if you follow the standardization activities in 3GPP, FR2 itself was a big new addition into the whole game. At that point, people were not very famous. Not many people have built receive transceivers for FR2. At that juncture, people were very wary to move to a new waveform. Already you're moving to a different frequency, you're talking about beams, you're talking about beamforming, all this were not there in FR1 at that point when they were building it. Okay? So they made this conscious decision, okay, let's just go with OFDM. Some waveforms were analyzed, but hello? Some waveforms were analyzed, but finally people stuck to people stuck to OFDM. On the downlink, if you look at the downlink, one of the major issues, as has been pointed out by Dr. Balaji also earlier, is that the PAPR, the power amplifiers that are available in FR2 at millimeter wave frequencies are not very efficient. Okay, even now they are not very efficient. And second thing is the amount of power that they can put out is not as high as what you can get in FR1. Coupled with the problem of PAPR, the back off, the amount of power that you're getting out of these devices is becoming low. Okay, so but on the base station you can do a lot of things. You can put a bigger panel, a bit larger number of antennas, and people are able to get out of this problem. They could get some right. But I think at least on the uplink side, it was a big issue. Uplink side, I mean, in FR1 itself is a big issue in 5G. I mean, if you open up your phone and see what is the modulation, uplink modulation that are ending up most of the times, if you have that app or something, you see you end up to QPSK, or if for some vendors, it even goes to pi/2 BPSK. Okay? So the same issue happens with FR2, but in FR2, the problem is much more higher because of this PAPR issue and the power amplifier is not in there. The question is, what are the different other waveforms that are there in there are other optional waveforms in FR2, but again, it's a question of implementation. It's a question of how many waveforms you want to put on your ASIC. Okay, there's a certain amount of complexity involved in this there. Okay, there are DFT spread OFDM already for uplink. Okay, but the question is how many vendors have enabled it in the base station and how many vendors have enabled it in the UAs. Okay, so DFT spread OFDM gives you a certain amount of margin. Now, so from my side, I think the way OFDM was chosen in FR2 was because of an evolutionary path. People didn't want to disrupt too many things at that point. I think that's a correct decision that they made. But now they're trying to think about other ways of improving the power efficiency handling, the beam management handling, and other things. That is happening. But going forward to 6G, I don't think OFDM is going to stay for at least terahertz. For sub-6 gigahertz and the FR1, OFDM is the waveform. I don't think any other waveform is going to disrupt OFDM for some time going. I mean, I don't see any great waveform as of now, other than OFDM. Let me put it that way. But once we go to terahertz, I don't think OFDM should be used. Okay, I mean, when you have such large bandwidths, I mean, sampling, number of bits that you require for demodulating OFDM, the vertical resolution of ADC, all this becomes an issue. I think we have to go to a simpler waveform which is easy to implement, has lower, extreme low PAPR, because there's nothing that's coming, no juice coming out of from the PAs, so I don't think we can back off anymore. So something as, I mean, again, I think we'll go back to some kind of PSK waveform or a single carrier waveform with certain modifications is what I think people are looking at, and that should be the focus of research. Yeah, thank you.
Thank you. Thank you very much. So just to follow up on that with Dr. Rao, so you have had a really impressive presentation on orbital angular momentum based transmissions. So could you elaborate on that? What's the role you see for that in future? Is it going to be a niche, or is it going to be kind of a mainstay? What's your thought?
Fine. Thank you. Can you hear me? Yeah. Okay, fine, hopefully. Right, to introduce myself, briefly, I started my career at Space Application Center, ISRO Ahmedabad, 1987, then moved to Samir. Then I've been staying with Samir for more than 33 years. I had my PhD from Queen's University, Belfast, UK. And throughout my career, it's been only antennas. So that was one luxury I had, so there was never a need to change my domain. And of late, in the last 5 to 7 years, I've been working more on RF systems and solution-based approach. I mean, closely working with IIT Madras, especially with Professor Radha. And I'm adjunct faculty at IIT Madras also, though I don't take many classes now. I used to take classes, but finally I'll go back there. Maybe I have only a few more years to go there in service. I'll be retiring in 26 and go back. So coming back to orbital angular momentum, the way Professor Radha mentioned, you don't need higher order modulations at these frequencies. You're talking about a huge amount of the bandwidth. I showed that MTT paper, which clearly shows that a basic QPSK or BPSK will do. And you don't need even a MIMO antenna system, which is going to be almost impossible at that frequency to create so many transmitters, receivers. So, but still you want to have large amount of data of terabits per second. So options available to you is, you can have the number of channels, the conventional what we did in MIMO, or we have the higher order modulation. That's why I showed that the animation. We already reached those places. We went to 1024 also in the OFDM and the QAM, and we went there, and as Professor Ganti mentioned, it's not going to be practical. It's even FR2 it didn't work. It's not going to work in terahertz. So we're going to come down to the lower order modulation, which is going to be very basic ones. So you don't going to get large amount of the data advantage going for the lower order modulations. Then I have to be left with the two options. I have to have MIMO. MIMO is going to be much more complex. Even FR2 we are not gone to MIMO because the prohibitively expensive millimeter transceiver systems to be deployed under each channel, what we do at FR1. So having MIMO also ruled out there. Then third option what we have is the bandwidth. Of course, we have good amount of the bandwidth available, but still that doesn't give the overall, whatever unless you have few gigahertz bandwidth, you see that graph, if you remember, you need 120 to 120 gigahertz bandwidth to get 1 terabits per second. You want to have a basic QPSK. That is also large bandwidth I mentioned during my presentation. RF you can have that bandwidth, but can your baseband handle that amount of the thing? So that's not going to be practical again. So that's why the concept of OAM is, it's not that I introduced or anything. It's kind of a lot of research papers were there. And as I mentioned, the trigger was when they showed 200 Gbps over there, a small news item, one of the Chinese government supported a demonstration. One of the demonstration, they showed that they used the vortex waves. Then we started digging them and found that only way of getting them is the way we have in FR1 or FR2, we call it the polarization diversity. You have the MIMO has the spatial diversity, and we have the over and above, you can double that entire data rate using the polarization diversity. You can send in slant 45, slant minus 45. You can create a redundancy, or you can break the data and send one stream there in one polarization, other stream in other polarization. And that is possible with the vertical and horizontal. It was possible for right-hand CP and left-hand CP. But it always limits to multiplying of 2. That is not sufficient, the kind of standards what we expected and the expectation of terabits per second. So you need to have multiple levels of sending the data in multiple channels, not depending on MIMO, not depending on the modulation. Then we thought the conscious decision from our understanding is could be OAM. And this has been used in optics, extensively used in optics. It's not that concept is new for 6G. In optical communication, OAM is extensive. But question is, they don't use the same frequency there. They use the wavelength multiplexing also on the OAM. The way the number of publications we have them, especially from antenna perspective, the complexity lies in antennas here. Generating OAM, creating the phase orbital, I mean, they have to have orthogonal to each other. Each mode should be orthogonal. You have mode 1, mode -1, +2 mode, mode 2, mode -2. So you have the 5 channels now. Coming from the same antenna system, except that your source will be the same, bandwidth is the same, you are generating only the phase, the progressive phase among the each element which is coming out of the antenna system is generating the specific wave. So this is a possible solution. But practically to realize that, creating the orthogonality of multiple number of modes on a free space, line of sight, wonderful. If any small disturbance comes, especially at that frequency, can you maintain that specific orthogonality? It's going to be challenging. So probably 1 year down the lane, we're going to propose, we're going to demonstrate, leave this 23, 24 IMC, you can see, I mean, at least what we planned, you can have OAM demonstration happening there. Probably that can give more insight that whether OAM is suitable or not. But according to me, I strongly believe if you want talking about terabits per second without changing the bandwidth, without going for MIMO, going for the lower order modulation, you don't have many options. If you really want that, you have to hit that kind of a data rate. Thank you.
Yeah, thank you, Dr. Rao. That was great. Yeah, looks like certainly very, very promising, and there's a lot of work globally in this space, and we look forward to that. So now I'll direct the next question to Rohit from Qualcomm. And the topic, we are moving down in frequency to upper mid-band, and specifically the new generation of MIMO that's required to achieve what we want to achieve in this band. I think the industry has still not coalesced on any single name for it. All the superlatives are taken, super MIMO, ultra MIMO, giga MIMO, extreme MIMO, whatever, we don't know yet. So, but the notion is that there will be, a couple of thousand antennas, and basically we may have, very large number of streams of MIMO, moving closer to the original vision of, Mazzaretta when he talked about, massive MIMO, where the infinity. But, the question is it, anywhere close to realizable? How close to reality is it? The technical challenges, at least, seem quite daunting at the moment, especially on the, everywhere from the baseband processing side to the, the power dissipation in the antenna, which is already an issue. So, please give us, your thoughts and your wisdom on this thing.
Sure, thanks. You guys can hear me, right? Yeah, so maybe just a little bit about myself. So I'm Rohit Kapoor. I've been working in the wireless industry for about 20 years, all with Qualcomm. Of course, before that, I did my bachelor's from IIT Roorkee, and then I did my master's and PhD from UCLA. But that was, maybe about 20 years back or so. So after that, I worked at Qualcomm in San Diego for maybe 10 plus years. And the last maybe 8-9 years, I've been here in Bangalore. And all these years, I've really been part of wireless research, one way or the other. In fact, when I started in 2003 or so, I was part of the project where we were designing the first 3G air interface. It was called EVDO, I think if you guys may recall, right? And the rates that we are talking about, hundreds of megabits or gigabit. I remember we were trying to design for 100 kbps on the downlink and maybe like 30, 40 kbps on the uplink, right? That was the first target on EVDO, right? Maybe like 20 years back or a little bit more than that. So I think as an industry, we've come a long way.
Sorry, just to interrupt. I was on the EV-DV camp in those battles.
Okay, so I know. So EV-DV, of course, you can say, I guess, merged with WCDMA at some level, right? But anyway, I guess similar type of technologies, right? But I think, it's interesting that just as an industry, right, we've come such a long distance, and I can't think of any other industry that's like supporting 1000x or 1,000,000x rates, compared to 20 years back, right? So something for us to pause and think about, right? Anyway, having said that, beyond EVDO, then I've worked on WCDMA, HSDPA, 4G technologies, 5G. Also, I have a lot of exposure on Wi-Fi side, 60 gigahertz, right? I've had some exposure to a lot of different areas in terms of wireless research, right? Maybe having said that, before answering this question, Dr. Balaji, I do want to touch upon and add to what Kirti said about FR1, FR2. Maybe I'll just take a minute or so on that. This FR2 discussion is really interesting, and since I've seen a lot of things on the 60 gigahertz side as well, especially when it comes to 802.11ad, AY on that side as well, right? And this question does come up all the time, right? What applications, what is going to really, justify or require these kinds of rates, right? And, I think my view on that is really twofold, right? One thing is that if you look at, for example, some of the applications, and I think we'll start to see some of them now. I've personally been involved in some projects where we've designed some XR and gaming type of, you can say support for these applications, with the appropriate wireless design. And what ends up happening, right, is that while most of these require maybe not more than 100, 200 megabits data rate, right? But the difference is that they require this data rate not as an average, right? What they require is that this type of data rate in a sustained way. So even at the 95th or 99th percentile, you have to be able to get this data rate. Otherwise, these applications don't work well in terms of user experience, right? And that's where this humongous amounts of bandwidth and data rate really come in. To be able to get, you apply any sort of probability distribution, whatever you have in mind, right? With some notion of how the channel is changing or some notion of how the load is changing over time. To get 100 megabits sustained is not easy. You'll require maybe 5x of that, 10x of that in terms of peak data rate support to get there, right? So my view is that that's really where I feel, as some of these applications in terms of gaming and XR start to happen, right? The requirements for that at the tail latency are so tight, right? That you need these kinds of this kind of bandwidth to be able to, these kinds of rates to be able to support that, right? And the scenario for that may not necessarily be the wide area, because that may not be where these applications thrive, but it'll be the hotspot type of coverages, right? Like, for example, if you have a number of people in this room, wearing, AR glasses as an example, or if you have a number of people in a house playing games, right? Those kinds of scenarios will really need that type of support, right? So I just wanted to touch upon that, on at least what my view, having seen a lot of different technologies, is on FR2. And it's true that we are not there today, right? But with all of this, I feel it's like when, I remember when EVDO came out, all my friends used to ask me, hey, what are people going to do with 100 kbps on the phone, right? Till the iPhone came out, and that answered everybody's question, right? So I do feel that, the right device, the right user interface will come out, which will make the best use of this, right? So I just wanted to, touch upon that. Having said that, to your other question, about whatever we call it, Giga MIMO, Ultra MIMO, right? I think in Qualcomm we call it Giga MIMO. That's a term we've been using. So as far as how real it is, what I can tell you is that, from our own experience in Qualcomm, because one of the things we do in Qualcomm is that, in addition to a lot of theoretical, analytical work, right, the charter of like the Qualcomm wireless research is to actually build prototypes, right? So we build a lot of stuff as well, because there's so much more that you learn when you build. You build, you kind of feed back that learning into your algorithms and so on, right? So we are at a point where we have what we call a Giga MIMO system running in a limited area in San Diego, right? And in fact, we did a demonstration of that at the recent Mobile World Congress as well. And what we are able to show, by the way, with that is that, with the right number of antenna and elements and the right design of that, we are able to actually achieve similar cell coverage as FR1, right? So hopefully, and of course, I won't say, I mean, this is of course an R&D prototype, so a lot needs to happen, to take it from here to make it more commercial ready. But at least as a proof of concept, we do see that that a Giga MIMO type concept, right, or whatever other name we have for it, we think it can be made to work, right? Yeah, with a similar type of coverage as FR1. Hopefully that answers it.
Okay, great. Thank you. I just have a quick follow-up to you, maybe. There is always, there is a parallel question of protocol split that's always happening. And to me, even personally, the fact that 7.2 is somewhat of a universal split right now does not necessarily mean that it has to be for every newer generation, and there are lots of trade-offs. So from that point of view, do you have any thoughts for example, this kind of a Giga MIMO scenario?
I guess what you're asking is what is the right type of split that would work for that. Actually, I'm not so sure myself, to be honest. Maybe I have to, I don't think we have looked at it to the next step, right? That's really the next step when it comes to how do you deploy these, right? What's the right split, right? I think we are at a stage where we've built a very focused prototype, is what I would say, right? Yeah.
Thank you. That's fair. But I think that's a question that eventually we'll have to all deal with because there is a huge fat pipe that's required on the front haul if you want to maintain that kind of split as well. So in the interest of time, we'll move to the next topic. Something very relevant, I would say, universally, but also specifically in the Indian context. And maybe I can direct it to Dr. Rao. The question of universal coverage, right, especially rural coverage, it's not just in the Indian context. Even United States has the same kind of issue. Just like you can't force airlines or trains to go to every small town, the same business aspects are also prevalent where cellular coverage, towers, infrastructure, it's very hard to get them going to rural areas. Are we making the right choices? What should we be doing differently in 6G? What are your thoughts?
Thank you. Can you hear me? Right. So maybe just a little deviation from the topic. I answer in a roundabout way. There's a couple of new initiatives taken by Government of India. So we launched, you saw the Prime Minister launched the 6G vision document. It covers that also. The rural connectivity is one of the topic which is written there. It's not that what you get in the urban area, the 6G data rate. To be honest, even I not moved to the 5G phone yet. Still I survive. So you don't need to move with the technology for survival. The basic necessity needs which need to be done there. The way we look at the rural communication, we exist there. It's been happening there with the 2G phone or 3G phone or 4G phone happening. We start looking in a much different way, especially the medical side. The connectivity of them, I mean, not having access to the medical resources, especially one of the key takeaways, you call it as a 6G vision document or anything, it's been talked about much seriously. And we started a new, it's called India's Bharat 6G. So we started the way we have NextG Alliance sitting there in US, we have the Bharat 6G Alliance started. There are 10 to 12 of us are founding members, and we are going to extend that where all this thought process from the industry, and we are going to get representatives from at various levels, and even from the multiple departments, multiple domains, and bring them on board and start creating the roadmap are the solutions and the technologies what we are building. They are not the governing body, but these are going to the advisory role. We have the high level body, which is the way we have HLF, high level forum for the 5G, where Professor Walras was chairman and multiple secretaries or members. Similarly, we have the 6G also, where few of our members there. So that is the one which feeds to the the government. And this, the 6G Alliance, what we call Bharat 6G Alliance, is kind of one of the in-between medium, called the mid layer. We are going to have the representation from industry, the user, and the last mile also. So that is one which is going worked out. But effectively ask whether 6G is going to make the life of a villager, I don't know. That's the answer. That's not going to, I cannot say that. But question is, but the way we talked about the 5G, then ever we talked about FR2, why we talk about FR2, FR2, so much there. The killer application which we missed, that we thought it could be the doing the remote surgery. And we got with such a low latency, the 5 milliseconds what was claimed. I guess, I think it's achieved 5 milliseconds, but still not that you are going to put on yourself in a kind of robotic surgery, say that I am safe there because 5G is their backbone. No, that's still 6G, they're talking about 0.1 milliseconds. That's going to change the entire this kind of connectivity. So, but in terms of the governance, if you ask me, that is going to make a huge difference. The way you talk about digital twin, that's one which is going to have, there is especially take about the Northeast. Very few people, few of us visit, and the connectivity is very, very difficult there. Even government is putting so much effort to make them connected there through the multiple 4G networks thing. If the digital twin is my perception, I may not be completely right. If you can map the scenario in the model wise, in the physical domain, and you can tailor-made the solution, probably that may be the better way. See, the way, whenever you want to lay the road, we remember when studying in the college, so the civil engineers always take theodolite, start doing it. We never understood why they do, but at the end of the day, the road will be laid. So like that, we don't do that. We do some ambient survey of the frequencies and do it, but that doesn't work in the Northeast. That kind of terrain, this kind of the models, none of the models going to work there. So if we can have a kind of a completely next generation enabled, a digital twin, and you can create the physical layer there itself, including the building and the rope, you can create the complete, you can simulate the actual scenario as a physical model in a digital domain. Probably a solution may be more addressed to that specific application, which in turn probably can have a better implication. That's one way I could look at it. Otherwise, you get in terabits per second, gigabits, and what way it matters to the villager. We don't have the basic need. So it's only for us to talk sitting here. So that's my conscious thing. I can say that can change the implementation. What are the maybe government scheme? I could be having a simple kind of a medical camp even. So where to put there, where to get the connectivity, how can really address there are 200 villages. You'll be surprised if we have it's a very interesting thing. In the present, our working style, our Honorable Minister Vaishnavji, once we have called Chintan Shivir. All like we were 200 people are called to the room, morning 9 to evening 3. We are asked to work on 4 multiple topics, divide into 4, we call verticals them, and you discuss among themselves and give a presentation. And evening he came that, of course, there is never a stage. All were sitting there and around the tables. This was all, more or less, we start avoiding this kind of a stage and we start saving half an hour of this inauguration ceremonies. Nice, we did the similar here. So the one question was given to us is one widow sitting in somewhere in the tribal, it's a tribal widow, doesn't know the language, doesn't know the communication, sitting in somewhere in the deep, in the forest or maybe in the hilly terrain, and she's entitled for, like any other citizen in the country, entitled for the benefit what government provides. How do you reach and locate? That is the question challenge posed. So this is the place where your technology can be, configured. Not that I have a solution. You cannot put the entire workforce say that, because minister said or prime minister said, I'll go and find that person, give the benefit. That doesn't solve the problem. We're talking about the solution without you moving, without moving your infrastructure, entire infrastructure. Are you really, when you say that we have developed, I have reached the point and my villages are connected, are you able to get that kind of the image or maybe the solution without using or wasting the resources? Are you able to reach the last person or last mile, whatever you call it? Then I feel the technology makes sense. Is the data rates doesn't make sense.
Yeah, true. Actually, Balaji, if I may just add a couple of quick points, right?
So
I think just purely in terms of technology, right, at least the 2 things I can think of in 5G as well as 5G advanced, leading to 6G, that can take steps towards, towards sort of broadening the coverage, right? One is going back to FR2. FR2 is in a lot of ways very well suited for wireless backhaul, right? And we have had some experience with that as well. It can provide really high data rates, and very easy to install that as well, of course, compared to digging fibers. So I think that's one thing. The other thing is that there's of course, the whole satellite NTN in 5G, and it's likely to get evolved in various different ways in 6G as well, including there are efforts to see that satellite as well as regular connectivity, can they work on the same band as well? And that requires, to solve its own set of challenges, right? Because the Doppler that you need to handle between satellite and regular communications is very different, right? But I think those are at least a couple of steps from a 5G, 6G technology point of view that I see could enable us to take steps there.
To add on to one point, maybe see, probably the one solution, probably was Radhakrishna sitting there, 5GI. We have another the standard which we got LMLC, low mobility large cell exclusively meant for Indian rural. Probably he can highlight on top of it. That's another solution which terms, of course, backhaul, even we had VSATs from the long ago. The VSAT, we are connected. But are we really at the same level of the standard what sitting in the city we are getting it? So that's where the question comes. Of course, backhaul, as I mentioned there, we have the effort to backhauls, even 60 gigahertz. Even Samir has maybe to add on that. Samir built the entire WiGig solution, not on the modulation side. We built the entire RF WiGig access point and everything there. That it's nice there in terms of the lab there. You can have a Wi-Fi router. But that's the minute you get onto that, if you had to send a 60 gigahertz backhaul link, it's going to be a challenge there. F40, yes, that makes a difference. He's talking about the 6A, it's still, one thing could be non-terrestrial network can make an impact. That we want to add on to the point.
I think,
thanks for that.
Thank you. I think you answered.
Thanks.
That was the next question I had, but it's been kind of answered. I think NTN maybe an answer that's already, somewhat, I wouldn't say mature, but at least already deployed and the learnings can be used. So thank you for the very lively discussion. I think the rural coverage and universal coverage is a very important topic that we all as technologists should not forget as we talk about these terabit rates. So the next question, maybe the last couple of questions, I'll direct it to Dr. Kanti here. So joint communication and sensing, right? First, do you see that as a viable use case? What are some of the drivers behind the need to do that? Is it simply more efficient communication itself as the end goal, or all of the other types of use cases that are being talked about, so some kind of 3D imagings and things like that? So,
excuse me. So even in 5G, localization is one of the big promises of 5G. I mean, the 5G promises almost 10 centimeter accuracy localization. But as of now, this still is a very tough and a challenging problem to solve. I mean, a lot of people who talk to me, specifically from the industry side, say, if we install 5G base stations, can we localize a cell phone or a particular device or something for their industrial setup to 10 centimeter or 5 centimeter accuracy? At this moment, the answer is no. Specialized simulations and other things, we can get 5 centimeter accuracy, but in a practical scenario, getting that kind of accuracy is very difficult. Okay? So this is where the sensing, I think this is a precursor to this whole notion of sensing and communication. At this point, what we were doing is, we are using the same 5G waveform and trying to localize a particular cell phone. Okay? So just taking this a little bit ahead, where sensing and communication. So now the question is, can we design efficient waveforms which can localize? Once you localize something, you can also make a map of the environment. I'm hoping that that's one of the ways. And at the same point, communicate, okay? I think this makes a lot of sense. There are a lot of research that went into this from a lot of time. A lot of people are working on this kind of joint sensing and this thing. The question is now, how do we modify the waveforms so that this is possible? We should not sacrifice the communication efficiency. That was one of the main criteria, because bandwidth is expensive. But at the same time, we should enable the use case of localization and even imaging imaging is going to play a big role. Localization is the first step. Imaging is the second, RF imaging is the second step. I think it makes perfect sense for this to be in 6G.
Great, thank you. The last question from me, and I'll direct it to Kirti. So, we are all sort of more, there are R&D people who dream up these things, and then there are people who have to actually implement them. Right? I know that you are very involved as a modem designer, and from that vantage point, when you see all of these requirements, what keeps you up? Right? What are you most worried about?
So first of all, it keeps us awake whole night because competitors are making new chipsets. Like I have one sitting in front of, and we always have to, sometimes ahead of them or catch up to them, because if some customer is getting a chipset, then we also have to do the same thing, right? So that's the frank answer. But yeah, what I realize is that you take any technology. So 5G specifications are having answers, whether you take cost perspective, for example. So then they came up with NRU, that okay, operators no need to pay. We can have NR over unlicensed, right? Then we have FR2. Then we have positioning also, like what Professor Ganti said, right? Yeah, release 16, yes, accuracy is less. But on theoretically, release 17 and release 18, enhancements are made to the positioning framework, and we are implementing them here. And we are seeing that, yes, theoretically it is possible, but lot of challenges are there. I mean, when we implement something, are we able to test it? So equipment manufacturers, are they, the test equipment manufacturers, for example, are they also having at the same pace what operator is asking? And many times what we are realizing is that specifications is covering so many things, like even we did not discuss, for example, V2X. There is so much happening, but as a team with a limited resource, we are always in dilemma where to put our resources on, right? There are so many technological directions, but whether everything can be implemented, what phase can be implemented. So these are the typical challenges what we are seeing, that we need to prioritize the features, and we need to see that what market wants, and do it just on right on time, so that you are relevant as a chipset vendor, you are relevant in the market segment, and as well as useful to the society in general. Yeah.
Thank you so much. I'll leave it to the time managers. Do we have time for any audience questions, or maybe one or two? Yeah. We can take one or two questions. Yeah, I see one hand.
One second.
Yeah. My friend Vikash, I knew he will have a question.
Thanks, Balaji, and all the panelists. Okay. Myself Vikas from Reliance Jio. So one of the most talked about use cases of the future technology is the CV2X, and you mentioned about this recently. So what do you see from the Indian perspectives, that where the CV2X makes a play as a next use case in the Indian context?
So very good question, and these are also have some kind of Chintan Sivers within Samsung. So we debate, okay, what we should do next, right? So what we are realizing is in India as of now, we are lacking behind. What I get to know is China is very much into CV2X, right? I heard that they have developed some kind of 5,000 kilometer range of test bed, something wherein practical prototypes and those things are under plan. So what I hear is that by 2026 or by 2027, CV2X will become reality. Right? So connecting your modem to everything, right? Car to everything from that. It's very costly propositions. Lot of industry players as well as government support has to be there, because it's like V2X. X means anything, right? Whether it is all kind of infrastructure points and the protocol standards and so on. So I feel we are, as of now, a little bit behind the countries like China. But I feel this is one area which in India all of us can focus on, and there is a lot of scope. Future is C2X definitely. Samsung is also a big player in automotive segment, and we have made a lot of investment into this. Our other sites are working into this. But yeah, as a whole, in Indian segment, much of the industry has to come together and work on it together.
Thank you. Yeah, I think we are, yeah, that's it, yeah. Yeah. Thank you all. Please stay. We have a small memento. Thank you all. I mean, this was a very enlightening session, right? So I would request Balaji to hand over a small memento to each of the panelists here. So Balaji, you can just read out the name and photo session. Hope there is no mix-up. We'll have a picture together. This is some fancy thing which Gautam got from Barcelona. One more. I will manage. Yeah, a group photo. One second. Sorry. Yeah.